Hi, thanks for joining me for Full Steam Ahead. Today I want to look at the science of milk. So what we're going to need for this experiment are some flat plates, some dish soap, some food coloring, some skewers or Q-tips, and milk with different fat contents. What we're going to do is we're going to experiment and see if the fat content of the milk determines the results of the experiment and see if it changes anything. So we're going to start by looking at how dish soap reacts with water. Now, one thing that we need to go over is we're going to look at this on a molecular level. So one thing to remember is that water has polar molecules. Milk has non-polar molecules, and the dish soap has both. And the molecules attach to each other. So the polar in the soap attaches to the polar molecules of the water. And the non-polar molecules in the soap attach with the non-polar molecules in the water. And kind of like how magnets, when you put magnets together, they attract and repel each other. That's kind of what's going on with this experiment. So let's take a look. So first we're going to see how the water reacts to the dish soap and see what happens. So just put some food coloring in. And then with your skewer, you're going to dip it into the dish soap and then put the skewer in the dots of food coloring, and we'll see what happens. So as you can see, the food coloring breaks the surface tension. And then after the surface tension has been broken, there's no movement. So the molecules of the water and the molecules of the soap have attached, and they've pushed the molecules to the edge of the plate. So let's see what happens with the milk. So first we're going to see what happens with a fat-free creamer. Okay, so dip the skewer in the dish soap and then put it in the food coloring. Now as you can see, it's moving a lot more. And unlike the water, it's not stagnant after the initial reaction. It continues to move. So what's happening is the non-polar soap is attaching to the non-polar molecules of the milk, and they're twisting and trying to attach to each other. So you see a lot of the continued movement until they've all attached. Here we have 2% milk. So we'll see how this one reacts. So the initial reaction is when the soap attaches to the water in the milk and it breaks that surface tension. And then you see that movement after that initial surface tension is broken. The movement in the milk is the fat. Here we have 18% coffee cream, so there's quite a bit of fat content in this one. So we'll see how that high fat content reacts. So there's a lot of movement in that one. And as you can see, after even a minute, it continues to move and attach to each other. So here we have buttermilk. Buttermilk has very high fat content. And because milk has a lot of water, you see that initial separation of the surface tension breaking. But let's see what happens with the buttermilk. So you don't see that surface tension breaking. Now what is interesting with this one is you see almost like branches coming up. So that is the fat connecting with the soap. And there's not as much movement after that initial attachment. Even when I add more soap, there's no movement. So this is whipping cream. Whipping cream has 35% fat content. So we'll see how this works. Hardly any movement at all. It's too viscous. You see a little bit of movement, but it does take a while. There's less water, so it doesn't move quite as freely as the other milks with a less fat content. But you can actually see the movement of the milk right in there. You can see it moving up these branches. The last one I want to experiment with is glue. Glue is made up of non-polar molecules like milk. So I wanted to see how it would react to the non-polar molecules in the soap. So you don't see the surface tension breaking like it does with the water, but you do see that branching like you saw in the whipping cream. It does move like the whipping cream because it's viscous. And unlike the milk, it doesn't continue to move after that initial movement, and the branch, after it branches out, it stops moving. Now, if you wanted to, You could dry this and it makes a beautiful sun catcher.